All right, y'all, I'll have y'all sort of help me on this. Big question number one. This is for y'all. Is this function they're showing odd, even, or neither? So remember, even functions are symmetric to the y-axis. Odd functions are symmetric to the origin. So y'all, I'm going to pull up my chat. Kieran, you're saying B, even. Good job. So that is definitely even because you can fold it over the y-axis and it'll land on itself. And y'all, it's also touching the x-axis 2 times, which is an even number. All right, so you'll put even, and then we'll go to the next one. So this is when we did the transformations in 7-2. They're giving me a function, g of x equals x plus 5 squared plus 3. So you got to come down here. It says start with the graph fx. So y'all, we had about 7 basic graphs here. So since you said exponent 2, this will start as the basic graph of x squared. So now it says shift it blank 5 units. Now notice the 5 is inside those parentheses. So when the 5's inside the parentheses and it's positive, would y'all say right, down, up, or left? Oh, good job, y'all. Definitely left. Remember, if it's inside the parentheses being added, it's going to go left. And then it says shift it blank 3 units. So there's a 3 at the end and it's positive. So when we throw a positive number at the end, it's going to go, good job. It is definitely going to go up. So you just had to tell me what them 2 numbers were doing to that. Then we got to click to enlarge the graph so that we can actually graph this. Now remember, the shape of the x squared graph is the U-shaped x squared tool. So you're going to click that, and then you click anywhere on the graph. It always starts it right in the center. So then we go over here. Since we moved it left 5 units, we're going to take the horizontal shift and drag that to -5. So that moved my graph left 5. And y'all, to +3 would be a vertical shift. So we move that to +3. And it moved my graph up for me. So at that point, you can save that and move on to the next question. All right, y'all, so they're giving me f of x equals the square root of x plus 10. So we're going to start with the graph of g of x equals the square root of x. And then it says shift it blank, blank units. So what is that plus 10 doing to my graph? And you just got to remember one thing. When it's under that radical, you treat it like it's in parentheses with the x. Okay, y'all? So you done picked the graph. So let's finish this out. So it says shift it blank 10 units. Now remember, if it's under the radical, y'all, it's going to go left or right. You got to treat it like it's in parentheses. Okay. So let me actually write this one down. This is what, number 3. And I got f of x equals the square root x plus 10. All right, y'all, so I'm going to pad on this one. So remember, if it's under the radical, you gotta treat it like it's in parentheses. So y'all are saying up 10. Y'all, for this one to go up 10, it would have to look like this. That 10 would have to be outside the radical to move me up or down. Okay? But my 10 is under the radical, so that's either going to go left or right. So if we're adding the 10, y'all, this one will actually go left 10 units. Okay? Now y'all watch this. Another way you can look at that. Let's go to our calculator and see what's happening. Remember, if you're unsure of those, go to y equals and grab your square root and put an x plus 10 in that. So notice my x plus 10 is under the radicals. Watch what happens when I hit graph. Y'all notice, it's not starting in the center no more. This thing is way over here at -10, starting its graph, okay? So that's actually going to move us left or 10 units. And y'all, let's see, what a graph we just drew. What are y'all going with, A, B, C, or D? Well, y'all remember which one went left? That has to be A, right? A went left 10 units. So you're going to click A and then move on. Now, this last one here, number 4, we don't have to graph it. We just got to tell it what the moves are doing. So we got g of x equals negative x minus 6 squared plus 5. They're telling me we're starting with the graph hx equals x squared. So now we're going to shift it. So it looks like we're starting, they always start with the parentheses. So since that 6 is being subtracted, that you got right 6. So we're going to click right 6. Then reflect it across the x or y axis. And actually, we only used one of those at this point. The only axis we reflected over, good job, was the x. And y'all then at the 5 at the end that says shift it blank units. So up 6, down 6. Well, we done did the 6s. That moved us right. So it's either up 5 or down 5. So y'all are saying up 5, so good job. Okay, so just sort of go through on that one and just fill it in. Just remember, the only axis we reflect across is the x-axis at this point, okay? Oh, y'all, let me write number 5 down here. They want us to find the zeros and are giving me f of v equals v squared plus 14v plus 48. So y'all, we'll say this one. On number 5, we can factor this one. But then they're going to give us number 6. On number 6, it won't be factorable. So on number 6, we're going to have to use the quadratic formula. But y'all, I'm going to factor this to solve it. So I'm going to set v squared plus 14v plus 48 equal to 0. Then we'll come in and put our parentheses so we can factor it. The v squared will be a v and a v. Y'all remember what we said, the last sign's positive here. So anytime the last sign's positive, both of these factors will have the same sign as the middle. So they're both going to be positive. So y'all, the trick now is to find factors of 48 that'll equal 14. Now remember, if you're weak at finding factors of a number, let me show you how to find factors of 48 on the calculator. So I go to y equals. So since 48 is the number I want to find factors of, I do 48 divided by x. Now, when I go to the table by hitting second graph, notice 0 is not a factor, but you got 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. And if you need more, you can just go down and see that it starts repeating like 8 and 6 and stuff. So I pretty much got all the factors right here. So the pair of factors that'll add to get 14 are going to be 6 and 8. 6 times 8 equals 48. 6 plus 8 equals 14. So that's the numbers I needed. So I would put in my 6 and 8. And y'all remember to finish it off, you set both of those equal to 0 and solve. So basically, I'm going to subtract 6 on the first equation. I'll get v as a -6. Remember, the zeros or solutions are always opposite in sign than the factors. So this was a +8 as a factor. So notice that ends up being a -8. So number 5, you're going to be able to factor. Now, if you don't like factoring, you can actually solve it by quadratic formula, okay? Which takes a little bit longer. So right here, you would just put in your two answers, -6, comma, -8, okay? And then you move on to the next one. Now, y'all, this is what I was saying you'll probably have to use the quad formula on. They're giving us f of x equals 3x squared minus x plus 9. So they want exact answers. That means no decimals. They want radicals if they're still there. And if we get complex numbers with the I, that's the ones where we got to sort of split them apart. So let's hit this with the quadratic formula and see what we get out of this, okay? All right, so I'm going to write the formula here. X equals -b plus or minus square root b squared minus 4ac all over 2 times a. So a, b, and c are these numbers. A will be 3. B will be a -1. And then c is a +9. Hey, also, it's just a matter of plugging these numbers in for the variables over here. And then we just start simplifying this, okay? So we got x equals a negative b, which is -1, plus or minus square root. Well, b squared will be -1 squared minus 4 times a, which is 3, and c, which is 9, all over 2 times a, which is 3. All right, y'all, so now it's just time to start simplifying. The negative times -1 makes that a +1, plus or minus, or radical. -1 squared is -1 times -1, so that's going to give you a +1. Now, everything over here is getting multiplied. So you got a -4 times 3 times 9. That's going to stay negative. And then, y'all, that's what -4 times 3 is -12. -12 times 9 is a -108. Y'all, all over 2 times 3, which is 6. So you know what's going on now. So now we got to subtract under there. So I'm going to get 1 plus or minus square root. All right, y'all, 1 minus 108 is a -107 all over 6. So now let's go to the side. Because to go any further, we got to simplify that square root of -107. And y'all remember, I gave y'all the perfect squares, 4, 9, 16, 25, 36, 49, 64. At that point, they're going to start getting too big. So, is 4 a factor of 107? No. Is 9 a factor of 107? No. 16 a factor of 107? No. 25 a factor of 107? No. 36 a factor of 107? No. 49 a factor of 107? No. Everything else is too big to be a factor of 107. So the number will not simplify, but y'all remember, there's a negative under that radical. So remember, I had to bring the negative out as a -1, and then that makes the 107 under the radical. But y'all, here's the question. Do y'all remember what I replaced the square root of -1 with? Oh, there you go, y'all. It is definitely an I. So this becomes an I square root of 107. So we can now replace this with that. So we get 1 plus or minus I square root of 107 over 6. Now here's the thing. Since this one has an imaginary part and a real part, we got to split it into two fractions. We got to put the 1 over 6 and then our plus or minus I square root of 107 over 6. In MathLab, we got to split it apart, okay? So let's go put that thing in MathLab. So what I'll do is I click it, I hit the fraction first, and I'm going to put in my 1 on top, arrow down, put in my 6, arrow right. Let's see, we got a plus or minus down here, yep. So plus or minus. Then I do the fraction again. I'm going to put in my I and then hit the square root, put in a 107. Then I'm going to arrow to the bottom. Well, let me click to the bottom and put in my 6. So y'all, this one has to be like two fractions, okay? All right, y'all. Once you put that in, you hit next. All right, y'all, so everything we need is on this problem right here. So the first question, you got two x-intercepts here. So for this question, it says the x-intercepts are, what would y'all put in that blank? Oh, I'll tell y'all what. Y'all are so close, but y'all see right under that, it says type and ordered pair. So y'all, if y'all just put that -1 and them 3's in there, they're definitely going to make y'all miss this. For the x-intercepts, they gotta look like an ordered pair. So that would be what? A -1, comma 0, and then put a comma in and put the next one. And remember, x-intercepts always have a y value of 0. Okay, so for the x-intercepts, definitely write them as an ordered pair. Now, when it asks for the solutions, well, the solutions are equal to the x value of the x-intercepts. So this is where y'all can come in and say -1, comma 3. Okay? So the solutions we can do, but y'all, those x-intercepts, you got to write them with the zeros as a point, okay? All right, y'all. So that was number 7. So let me ask, are there any questions at the moment? No, y'all, I'm not seeing nothing, so let's move on. Uh-oh, look at this. Here comes y'all's favorite question with the ladder. So let's just get the basics. The foot of an extension ladder is 5 feet from a wall. So foot of ladder is 5 feet from a wall. Now the height the ladder reaches on the wall. So height ladder reaches on wall. And the length of ladder are consecutive integers. Now look, all I want to know is how long is the ladder? So how long is the ladder? All right, so we're about to play with this one. We're going to work that on our pad here. So let me get our question up. So we're going to draw us a picture here. Here's me a wall sitting here. And I've got a ladder leaning up against it. Hey, y'all, the first thing I know is that the foot of this ladder here is 5 feet from this wall. So this distance right here is 5 feet. So what I need to know is what to put for the height here and what to put for the ladder. What am I going to use as my variables on these when it says the height of the ladder reaches on the wall here and the length of the ladder are consecutive integers? Do y'all remember what that meant? If they're consecutive integers, what would I call the height of the ladder on the wall? Okay, so that'll be my X, and then I think Jackson, you got it. Um, you said C plus 1, so good job. If this is X, this will be X plus 1. Okay, consecutive integers. If this is 4, this equals 5. If this is 7, this equals 8. So that's what they meant by consecutive integers. Okay, so y'all, I've got a right triangle. So to solve this right triangle, we're going to use our Pythagorean theorem that says a squared plus b squared equals c squared. So which of these 3 sides has to be my c? So you got the 5, you got the x, or the x plus 1. Which one would y'all put as your c on this problem? X plus 1, good job. So x plus 1 has to be c no matter what. And then this can be A and B, okay? Only one we're picky about is the hypotenuse has to be the C. All right, y'all, let's plug in. A is 5, so I got 5 squared plus B is X. That'll be X squared. That's going to equal X plus 1 squared. All right, so on the side over here, let's figure out X plus 1 squared. Now, y'all, I'm going to tell you this. When you work this problem, the only difference is going to be the 5, ever how long this side is, because consecutive integers are always going to be the x and the x plus 1. So this problem that y'all get is going to work exactly like mine other than that 5, okay? All right, y'all, 5 squared is 25 plus my x squared. Whoops, we got to FOIL that real quick to see what we're going to put here. So y'all, here we go. X times x is x squared. X times 1 is 1x. 1 times x is 1x. And y'all, 1 times 1 is 1. All we got to do now is add the x's in the middle. 1 plus 1 gives me a positive 2x, and then plus my 1. At this point, x squared plus 2x plus 1, your problem will have the same exact thing here other than that 25, okay? Now, y'all, everything else will be the same on these. But what we like about this problem, watch what happens when I try to move my x squareds all to the same side. Y'all remember that? The x squareds cancel here. They cancel here. So we're not even quadratic no more. All we got is 25. That's going to equal the 2x plus 1. And y'all guess what? All we got to do now is solve that for the x. So what are we going to do? We're going to subtract 1. That'll give us 24 equals 2x. Divide everybody by 2. So that's going to give me what? A 12 equal to my x. Y'all, listen, the only difference y'all are going to have on this problem is the numbers, okay? This right side will play exactly like mine. All right, y'all, so the question of the day, how long is that ladder? Oh, good job. Whew, good job. Most people put 12, but y'all remember the ladder was x plus 1. So 12 plus 1 gave us 13. Good job. So you got to watch that, okay? When you solve that, you're not technically done until you add that other foot to it, okay? All right, so we got 13 on that. So now we can move on to the next one. Hey, I'm gonna make this one bigger. Now they're giving you the picture here. And they're even telling you what that bottom point is. It looks like parentheses 1 comma 2, okay? So the first question, what would y'all put in for A, or for the part that says the vertex is? What are y'all putting in that? And notice, it says type an ordered pair. And y'all know what? It looks like they're giving you the vertex, right? So that point right there that they got in parentheses is our vertex. So we would put in a parentheses, 1 comma 2, and close those parentheses. Now, here's my next question. What is the axis of symmetry? And that'll be on y'all. So I want the axis of symmetry for that parabola. All right, so Jackson, although you got the right number, you need to do what Nat did and make that x equals 1. So notice this one has to be an equation. So you got to do x equals 1 on that one, okay? Now, let's see if y'all can get this. What is the minimum or maximum value of this function? And notice this one don't have to be in the form of an equation, just that axis of symmetry, okay? All right, so you got a minimum, but what's the value of it, Nat? So 2, good job. So Jackson, on this one, you don't need the x equals. All you need is that that positive 2 there for the y value, okay? So y'all notice, axis of symmetry, it'll say type an equation under it, x equals 1. Minimum or maximum value, it just wants the number, okay? All right, y'all, so then we hit next. So we probably got more, so let's see if this is true or false. The graph of h of x equals x minus 2 squared can be obtained by translating the graph h of x equals x squared. So they're telling us the basic graph is x squared by moving it left 2 units. Well, is that negative 2 inside those parentheses moving that graph left and making that true? Or would that move the graph right and make that false? So is this statement true or false? All right, what are y'all saying? False? Good job. Because remember, when we subtract from the x, it actually moves me to the right. So y'all, we would come in, put a false on that one, and go to our next. Hey, y'all, so let me write this one down because this one's going to be a little work here. Because notice, they didn't give us the vertex on this one. So we actually got to find it. So let me write this down. F of x equals x squared plus 10x plus 24. So let's see. So we don't actually have to graph this one, it looks like, but we got to find the vertex. We got to find maximum or minimum in the value. The range. So the range was the y values and then increasing and decreasing. So remember, the range deals with the y values, increasing and decreasing deals with the x values. So what we need for sure is that vertex. So let's go work this. All right, so once we get the vertex, we can then figure out that we got a min or max. So we know the vertex formula is negative b over 2a, and then f of that negative b over 2a. So we find the x value, then we plug the x value back into the function. So y'all, a is 1, b is 10, c is 24. Hey, y'all, let's see what y'all remember on this. My a is positive. So since my a is positive, will I have a minimum or a maximum? It will definitely be a minimum. Good job. So I know my parabola is going to have a minimum because a was positive. All right, y'all, so let's get the vertex first. So on the vertex, I'm going to get my x value, and that equals to negative b over 2a. So that'll be a negative times my 10 over 2 times my 1. So y'all get what? A negative 10 over 2. And that'll give us a negative 5. So here's my vertex. I know negative 5 is the x value. So to come in and get my y value, I'm going to find f of negative 5. That means I'm going to put a negative 5 in for these two x's. So I'm going to have negative 5 squared plus 10 times negative 5 plus 24. All right, so negative 5 gives you positive 25. 10 times negative 5 makes that a negative 50. And then plus my 24. All right, y'all, so let's see. 25 minus 50 is a negative 25. Negative 25 plus 24 is a negative 1. So my vertex is negative 5, negative 1. Now, y'all told me I had a minimum. Well, what's the minimum value of that parabola? All right, y'all, so that negative 1 is perfect. Then it wants my range. So remember, the range goes from this minimum y value, and the range goes upwards. Okay? All right, y'all, let me let one in real quick here. Now, we know the minimum y value was negative 1. So remember, on the range, you got to use brackets since negative 1 is included. And then what y'all say? It goes to infinity. Good job. So just remember on the number, you actually got to have a bracket on those, okay? So now it wanted increasing and decreasing. So increasing is this part of the graph going uphill, left to right. So what I need to know is at what x value does this start increasing? And then it's increasing as my x's go towards what? All right, I'm getting that one. Negative 5 infinity. Good job. Now, increase and decrease, and always use the curves, okay? The only time we'll use a bracket on this problem is around the number on the range. So from negative 5 on the x's to infinity, it was increasing. So now decreasing is this left side going downhill here. So what we got to figure out is our x's, where are they coming from and where are they going to? So now what's we got? Good job. We got a negative infinity. They're coming in from negative infinity until they hit negative 5. Okay, y'all? So on increasing and decreasing on a parabola, one side will start at negative infinity, go to the number. The other side will go from the number to a positive infinity. Y'all, I think that's everything we needed. So let's go plug that in MathLab and see what they say. So the vertex, you got to put in parentheses. And that was what? Negative 5, comma, negative 1, close parentheses. Y'all told me it had a minimum value, so it opened up and has a minimum value. And y'all said the minimum value was negative 1. Then we got the range. We said the range was the bracket, so let me find the bracket. And it went from negative 1, comma, to infinity. And then use the curvy parenthesis. Increasing, let's see, that y'all said that was what? Negative 5 to infinity. And close in parentheses. And then y'all said the decreasing was from negative infinity to a negative 5. Okay, y'all, so really on this problem, once you got the vertex, sort of draw it like I did. And just remember, ranges are the y, increase and decreasing are those x's, okay? All right, y'all, so then we didn't have to draw, so we hit next. Oh, now this was actually an application using the vertex formula. And y'all, all we're worried about is that equation they're giving us. H of t equals negative 16t squared plus 136t plus 4. Now they're telling us the rocket was shot from a launching pad 4 feet above the ground. That's why that 4 is at the end of the formula. Initial velocity was 136 feet per second. So that's what the 136t is. For every second on the t, that rocket's going to go 136 feet. So what about that negative 16t squared? What other force could affect the height of my rocket? And that's why this one's negative. And y'all, that'd be the universal force of gravity. So the negative 16t squared is the force of gravity on the rocket. That's why it's negative, okay? But y'all, you don't have to know that. We just got to find its max height. Is how many seconds after launch, and then the max height reached by the rocket, okay? So y'all, let me remind y'all, on this rocket problem, the time will be the x value, the height of the rocket will be the y value of it, okay? So time is your x coordinate basically, and the height will be your y value. So here's your x-axis and your y-axis. This rocket got shot off. It's going to go up and then it's going to come back down. We're looking for that point right there, which is our vertex, okay? And in the real world, the x-axis is usually some type of time, days, years, or whatever, okay? So to get the time, we need to do negative b over 2a. So let's get a, which is a negative 16. B is 136, and C will be 4. All right, y'all, so let me plug in. I got negative times B, which is 136, over 2 times my A, which is a negative 16. So I basically get a negative 136 over negative 32. Well, that's going to turn that positive because your time has to be positive, okay? So these two negatives will make that positive. So I just need to figure out what 136 divided by 32 is going to give me. So let me go to my regular calculator here. And I had what, a negative 136 divided by a negative 32. Y'all, that's going to give me 4.25. So that means in 4.25 seconds, my rocket reached its maximum height. So now I need to know what is the maximum height. Well, that's going to be F. Well, in our case, H of 4.25. Okay, because that's what my time was. So I put time in for this H equation now. So I got negative 16 times 4.25 squared plus 136 times 4.25 and then plus my 4. See, all decimals are fun, but I'm going to use my calculator on those. I'm just going to punch this in just like it looks on my calculator. All right, so let me clear everything. All right, so I had negative 16, parentheses 4.25, close parentheses, and square that. Then I had plus 136 times 4.25, close parentheses, and then at the end we had a plus 4. So y'all, it's punched in just like it looks. So if we hit enter, we get a maximum height of 293. So I know my vertex here is 4.25 and then 293. It took it 4.25 seconds to go this height of 293, okay? All righty, y'all, so let's go punch that in. So this is one of the few places on my test where it will take the decimals. So 4.25 and then 293. Now, the main thing you got to realize on this is that both of these answers got to be positive, okay? And then hit next. All right, y'all. So looks like we're going to do one more and then we'll be able to do our break here. So I want the domain f of x equals a square root 3x plus 10. All right. So with radicals. Oh, let me go back and see what C is. So I think you're right on that because I think you're. Let me work that real quick. I think you're pretty good on that, Nat. Good job. Because what I do is take this radicand, remember the part under the radical, 3x plus 10. It has to be greater than or equal to 0. All right, so what you do? You minus your 10. 3x is greater than or equal to negative 10. And then looks like you divided by 3. Now remember, I don't turn this dividing by a positive number. I would only turn that if I was dividing by negative, okay? So we get x greater than or equal to a negative 10 thirds. So that looks like you were perfect on that one. C has greater than or equal to the negative 10 thirds. Okay, y'all? All righty, so we're going to come in after break and mess with that one. So let me pause this. And then let's get back to the math lab. So 14 is just a graph and we got to pick a picture. But y'all, this in all reality, they're subtracting 9 from that x. And it's inside parentheses we treat it, remember? So if I'm subtracting 9 from my x and it's under that radical, would it move my graph left, right, up, or down? So it's going to move it right. And y'all notice, I got 4 pictures here. Let me make them a little bigger for you.